So 4.1 and 4.2. What is average? Average is what we're talking about central tendency. The measures of central tendency. Measures of central tendency is not mentioned in your book at all. Don't look for it. It's just the way I was taught it, and so I mention it and talk about it in this method, and it confuses people. I can't help it. Central tendency is where is the middle, and we have three ways that we're going to discover how to calculate the middle. And then we're going to talk about outliers and how they might affect them. And I'll show you some examples in class, but I just want to show you this part first. So mean, median, and mode. Mean is what we know as the average. We take the sum of all the values and divide by how many things there were. You learned this in 5th grade. Median, think of a highway, the green strip in the middle. That's the median. The median of numbers is you put them in row from lowest to highest. You find the number in the middle. If you have an even number of things, you take the two that are in the middle surrounding that middle number and find the average of those two. But the median is just halfway point. That's all it is. And the mode is the most common thing, the thing that happens the most in your data set. We use it a lot for qualitative data, not so much in quantitative data. The rounding rule that they're going to talk about, go one more decimal place, one more significant digit than you had in your data. So if everything is whole numbers, 2, 3, and 5, you take the mean, you get 3.3333, round to 3.3. If this had been 0.2, 0.3, and 0.5, and you've taken the average, you would have gotten 0.333, you would have gone to 0.33. So always go one decimal place longer. And here they have a note that if it's exactly the same number of decimal places as the data, you can either go one more or leave it alone. So an outlier is a number that is very much higher or very much lower than all the other values. My favorite example of this is the North Carolina geography graduation salaries, because Michael Jordan was a geography major at North Carolina, and therefore when he graduated, his starting salary was in the millions of dollars. It boosted the mean of all of the average of the salary, so they advertised that and would get a lot of geography majors because they thought they were going to get paid a lot. So an outlier has effects on mean. That's the big thing you need to know. Outliers don't have any effect on median, and so that's why we sometimes use one over the other. This table here just shows, the explanations of mean, median, and mode, the definitions, how they're calculated, what do we commonly use them, and whether it takes into account all the values, and if it's affected by outliers. Notice that the mean takes into account every value we have, and it is affected by outliers. Whereas the median and mode do not take into account every value that we are, and are not affected by outliers. Because we're only looking at, in the median, we're only looking at that middle number. We don't care what happens if there's outliers. And the mode only looks at the thing that happens most often. So, weighted mean, what we do with this is we find the weights usually has to do with testing, your grades. You say, well, the tests are worth 10%, the assignments are worth 15%, the homework is worth 20%, and so you take the total of each, you add up all the groups, multiply by the weights, add those all together, and then divide by how much the weights add up to. So the weights don't even have to add up to 100%. So that's something you need to know. Notation, I know it says optional, but you need to know it because we're going to see it all through the book. Sigma is the capital letter. Sigma here is for sum. We use it for sum. You see it in your Excel spreadsheets. Just means add up everything. N represents how many things there are in the sample. Just the number of things. So they're going to calculate here the sample mean, which is called x bar. This little bar over it. And that just means add up all the values divided by how many things there are. Sum of all the values of x divided by how many things there were, the n. X bar is for sample mean. If we're talking about population mean, we use the letter mu. So that's just the way it is. You'll see a lot of Greek symbols. There's also sigmas, and if you get into calculus, you'll see deltas. But so Greek letters get thrown around everywhere. So another thing we're going to talk about is when we have frequency distributions. Finding the mean and median when we have frequency distributions. And we remember these from chapter 2 and 3. We have our bins, we have our frequencies. And we want to find the middle. What does that mean? Well, to find our middle values, we have to find the middle of each bin. Well, the average here between 0 and 6 is 3. And the average between 7 and 13 is 10. And the average between 14 and 24 is 17. And the average between 21 and 27 is 24. And so we take those values and we multiply them by our frequencies. Then we divide by 50. That's how we'll get our mean from this frequency distribution. If we're looking for the median, well, we know we have 50 of them. We have to find the 25th and 26th values. Well, 10, 20, 30. So the 25th and 26th values are between 14 and 20. So that's where our median class is going to be. And we don't know the actual number, but we know it's somewhere in there. And we could give it a value of 17 if we'd like. We can see here that our mode is in the highest frequency bin, somewhere between 21 and 27. Again, we don't know the actual number, but we could give it the value that we found for our median, which would be 24 in that case. All right, so 4.2 talks about distribution shapes, and really talks about skewness and variation. Variation is how things are wide and the modes that we have. When we look at a distribution, we look to see how many bumps there are. Bumps tell us how many modes we have. This has a single mode. This is bimodal. This has a single mode. Okay, that helps us. That's why we smooth them off. We can also look to see if it's left or right skewed, and we can look to see how wide it is. How wide the curve is compared to other curves, and that talks about variation. So, a flat line is uniform. It has no mode, or basically everything is a mode. So that's what that is. A single curve like this has a single mode. This has 2 modes, and this has 3 modes, or multimodal. So, say single peaked or unimodal. Then they have bimodal and trimodal, and so forth and so on. We don't care that they're not the same height. We're just looking for bumps, and that tells us about how many modes there are on a graph. When we have the count of numbers, we look for the values and see which ones occur the most. But when we're looking at a graph, we look at the bumps to see if there's modes. Okay. Skewed talks about symmetry of a graph. Can we fold it over and have it be equal? All of these are symmetric. If we fold them in half, they look exactly the same. So we have skew. Skewing talks about whether or not the mean is where the outliers are. If we have outliers that are low, we're going to have skewed values to the left. Notice the mean is less than the median is less than the mode. If the outliers are high, the mean becomes higher than the median and the mode. So mode is less than median is less than mean. And that's how we talk about the two of them. If mean, median, and mode are equal, it's symmetric. So here we are again with the definitions. Symmetric if the left half and right half are mirror images. It's left skewed if the values are more spread, the tail is on the left side. It's right skewed if the tail is on the right side. So here the tail is on the left side because we have outliers that are on the low end. Here we have right skewed because the outliers are on the higher end. Now variation talks about how wide the data is spread. Notice here we have 3 graphs. This has all the points are very close to the mean, so we have a small variation. Here we have high variation because the points are all very far apart. Notice they have the same exact mean, but they're spread out. And so you can only really look at variation compared to other things.